The last ELR is ELR 2.7, and it's all about impulse. Impulse is the concept of changing your momentum. So anytime that you want to make something either go faster and gain momentum or slow down and lose momentum, it requires an impulse. It requires a certain amount of push over time. So the equations that we use for this, there are kind of two equations that equal each other. So impulse is the first half that I like to think about, and that's how much push you're giving it, force, times how much time. And it turns out that impulse equals your change in momentum. And change in momentum is like how much mass you have times how much your velocity changes, since momentum is mass times velocity. So when we set these two things equal to each other, it's actually a pretty powerful equation that lets us to gives us the ability to predict quite a bit. So in the first question, it's saying, why does it hurt more to punch a wall than a pillow? We've talked about this quite a bit in class. Well, if you're going to punch a wall or a pillow, basically you have your fist with a certain amount of mass going a certain velocity that you have to make go to zero. So you're going to make your momentum go down to zero. And so these two things are pretty much set. If you imagine this fist going slow motion into either a wall or a pillow, you've got to make this certain amount of momentum disappear. And in order to make that disappear, you have to have a certain amount of impulse. And so since impulse is force times time, you have some options here. If you have a really big force, a huge force, you are going to have to apply that force in just a teeny tiny little bit of time, and that will give you the momentum required. Your other option would be to have a really small force, and if you have a really small force, it's going to take quite a bit of time, so your time is going to be the big component. Well, if you're punching a wall or a pillow, it's this force component that's going to cause the pain on your fist. And so if you would prefer to not have pain in your fist, you're going to want a small amount of force, which is going to mean then that you've got to have quite a bit of time in order to do that. Number two, if you slam on the brakes of your car, a 1.5 kilogram watermelon you have in the passenger seat will go flying forward, objects in motion staying in motion. And it's going to go flying forward at that velocity. The dashboard of your car is going to stop that momentum, and it's going to happen in about a fifth of a second. What will happen, or excuse me, what will the force of the watermelon be? So for this one, we're going to use the same old equation, impulse equals mass times change in velocity. And so for this, we're just going to start plugging things in and see what we're left over with. So it's saying that we want to solve for the force. So force is what we're left with as a variable. It's telling us that it's going to happen in 0.2 seconds. That's our impulse side. Now we've got to go to the momentum side. Our mass is 1.5 kilograms. And the change in velocity, since it's going to be stopping, we're going from 5 down to 0. So that change is a change of 5 meters per second. Now we just need to start doing some algebra, plugging things in. We're going to go 5 times 1.5, and then divide by this 0.2. And we end up with 37.5. And now remember, don't forget your units. Since we're solving for force, this must be in newtons. And that is how much force the dashboard is going to put on our watermelon. The last one, what happens to the force on an object if you double the time, and what happens if you cut it in half? And then the third part is, what will happen to the momentum if you double the force but leave the time the same? So we're answering three different things at once. For this kind of a question, I always like to pick really easy numbers to do my math with. And so for this one, what we're going to do is we're going to say, let's make, so our force times time equals mass times velocity. So in this one, let's just pick 2's for things. So let's say that our force and our time, just under normal conditions, are 2 each. Well, if our force and our time are each 2, that means that our momentum is going to be 4, since 2 times 2 is 4. Now we can go into the question and actually start solving. So the question is saying, for the first part, what happens to the force on the object if you double the time? So double the time would be, instead of 2, we're going to go 4. So 2 times 4, well, that's going to equal 8. If I go from 4 to 8, that's a doubling of the momentum. So if I double the time, 2 times the time, we get 2 times the momentum. Then the question says, for the next part, what happens if you cut the time in half? Well, keep the force the same. Half of 2 is 1. 2 times 1 equals 2. So if I cut the time in half, it looks like I'm cutting the momentum in half. So half the time is going to give us half the momentum. Then the last part says, what's going to happen to momentum if instead of messing around with the time, you double the force? Okay, well, that one's going to go to a 4 instead of a 2, and the time stays the same. 4 times 2 is 8. 4 to 8 is double. So if we double the force, we double the momentum.